thing I want to leave you with is, and I suggest you try to create this and run some at home. Okay, so here we have people without diabetes, incident cases of diabetes, and the number of people who are getting diabetes per unit of time, okay? And then there's deaths of people without diabetes and deaths of people with diabetes. And here we have a value of 15 for the rate at which people get diabetes, 10 for which they die from those with diabetes, and 0 for those dying without diabetes. These are fixed flows right now, and both stocks start at 1,000. Okay, excuse me, the second one may start at 0. So what is the count of people with diabetes going to be doing in this case? What's the inflow, the total inflows to the stock people with diabetes? 15, and what's the outflow? Okay, so what is that value of that stock going to be doing over time? It's increasing. Okay, so suppose now, so good. Suppose that initially with the inflows to those with diabetes being 15, now suppose we make that inflow, so it's 15 for a long time, and then at time 75 it goes down to 5. What would the value of that stock do, the number of people with diabetes? What is it doing before this point, 75? In a linear way, and then after that it's going to, okay, and why will it decrease? Because the, good, so people, the rate at which people are getting diabetes is exceeding the rate at which there's death from it, and so it's rising, and then you have a lowering in diabetes, and it decreases, okay? It decreases from that value. It doesn't instantly get halved itself. This is the confusions people get in sometimes about halving it. It doesn't instantly get halved itself. The flow in gets halved, but its value doesn't get halved. Okay, suppose we have these flows. Flow in. So this is the red is the flow in, and blue is the flow out. What's the stock going to be doing then? Yeah. Okay. When is it going to be neither increasing nor decreasing? Under what points here? 2 points across. What is it going to be doing here in this sort of from 25 up to 75? It's going to be, is it going to be increasing or decreasing? Increasing, because the red, in other words, the inflow is greater than the outflow. It's going to be is it going to be increasing linearly? No, it's going to be increasing faster and faster. All right? The gap between them is growing. Okay, and then what's going to happen at this point here? It's going to be, yeah. So, okay, after that it's going to be slower. Is it still going to be increasing though? Yeah, it's just increasing slower and slower until it's the same. And so, so when is the stock of people with diabetes at its lowest value here? Far right. And why is that? That's correct. Yeah, okay, so you integrate the area between these curves. Here, it exceeds the area here, so it's gone down more than it rose here, and so it's lowest here. The other candidate would be if it were here, because all this time it's going down, and so it's possible. Okay, when is the stock of people with diabetes at its greatest value? Sorry? There. Why isn't it here? Yeah. What is the greatest here? The sort of rate at which it's increasing, the speed at which it's increasing. But the number of people with diabetes is actually highest here. It's been increasing. Initially it decreased here, but then it increased all the way through here, and it's continued to increase. after this point to continue to increase because the inflow is greater than the outflow, right? And all the way up to this point. And at that point, inflow is equal to outflow, so it's not increasing anymore. So it's been increasing all this way, so it's actually the highest here. And we talked about when I said not changing. So that's good. I'm going to ask, well, one final question here. Just make sure people. Suppose that the inflow here, in this diagram here, we had an inflow of 15 and then it was halved to 5. Suppose the outflow, ladies and gentlemen, were 2. Outflow of 2. Okay. What would this stock be doing? Excuse me. So I'll just to be clear here. So if this outflow was not 10 but 2, what would this stock be doing? So it increases, and it would be increasing, and then what would change at 75? Okay, would it still be increasing after that? Yeah, it'll still be increasing. The inflow has been halved. Excuse I don't know, my Latin fails me. It's been reduced by a factor of 3, but it's still increasing, the value of the stock. Just like I was saying before, I mean, if you could have really low, strong emissions regimes that come in, but unless they're stringent enough to lower the rate of emission across all things to be lower than the rate at which it's absorbed, you're going to still get CO2 rising. Unless the outflow is larger than the inflow, or unless the inflows become smaller than the outflow, it's still going to be running dramatic changes. You make, a change factor of 3, and you think you're doing a huge favor, but the stock's still going to rise. It's still going to have memory. It's like the elephant. It's still going to remember, and you're not going to be able to decrease it unless the outflow is greater than the inflow. So that's sort of a little bit related to this issue of inertia. The stock has remembered its sort of previous history, and to drain it, we need to often do drastic things with the inflow or the outflows to make it so the outflow is greater than the inflow to drain it down. Okay, so that's just a reflection. If we had an outflow of 2, we'd have to not just reduce the inflow by a factor of 5. We'd have to reduce by a factor of 3. So we'd have to reduce by a factor of 10. Okay, so I think that's all we're going to cover